You want to talk? Let's see. I'll present in English. Okay. So, hello, I'm Josh. I'm a PhD student at the University of Aveiro, working with Jose Alves and an international team. And today I'm talking about some work that we've been doing to look at connectivity in conservation. So, coming up, I'm going to briefly introduce the theme of connectivity and its importance to conservation. Then I'm going to introduce a case study in the Tagus estuary with some birds that we studied called godwits. And then a quick introduction to analyzing connectivity, because I think most people in the room don't do much of that. And then how we can use these analyses of connectivity to better understand potential impacts of development on protected areas and protected species. Okay, so we've been hearing quite a lot about protected areas during this conference, and they're often designated to conserve habitats or species of particular importance. And these species are often animals. Now, protected areas at the moment tend to be static. There's a lot of animals move, and this can create certain tensions, certain problems of conservation. So if we imagine a beautiful protected area like this, and a beautiful animal that lives in it like that, this animal might just move around within the protected area, but its movement might take it into the wider landscape, or for some species, it might migrate and spend some of the year in a completely different part of the world. So this static protected area is intended to contribute to conserving animals, which can move at a variety of scales, from local to landscape or international. And these movements of an animal could take it to another protected area, or just to some other place that has some value as habitat, but isn't protected in its conventional sense. And the ease or frequency with which these movements take place is what we consider connectivity. And this is a subject that's really taking center stage in conservation, not just in conservation science, but also in policy. So the Convention for Biological Diversity, for example, is really strongly considering how best to conserve connectivity in its upcoming biodiversity framework. And NGOs like the IUCN have been producing guidance documents on how to ensure that protected areas function best by connecting them to the landscape and to other protected areas. And I think connectivity can operate in two ways. So we often think about how a protected area can help to populate the wider landscape with individuals, especially in the context of, say, marine protected areas that are nurseries for fish, and then it provides extra fish to non-protected areas as well. And we can think about this as a protection footprint, then like we talk about carbon footprints and ecological footprints. So the wider area of a landscape that benefits from the protected area. Alternatively, the outside world can affect protected areas. If there's, for example, a development which negatively impacts animals that use both areas. And that would create an impact footprint, which in a similar way is a wider area of landscape that's harmed by environmental damage from this development. And that damage could extend to including a protected area, even if the development is outside. So we've got a few ways that you can infer connectivity from genetics or from community dissimilarities, but we can also measure it directly with animal tracking data. And as we already heard from Jose and other people, this technology is moving really fast. You can put tiny devices on birds, and they give you maps like this, telling you exactly where they've been all the time. My colleague João Bell has a very nice poster about this outside. I use slightly older technology, which is these colored plastic rings on a bird's leg. And then we go to the field, we identify this individual. And the advantage of this is it's cheap and it lasts the bird's whole lifetime, which could be 10 or 20 or even 30 years. And over time, we've built up a huge data set of thousands of individuals, tens of thousands of records of where these are and when. We've seen this map earlier today. So we have Lisbon is here, and this is the boundary of the Tagus estuary special protection area. So this is Portugal's largest wetland. It's one of the most important wetlands in the East Atlantic for migratory water birds, including for the black-tailed godwits, which is the species I'm going to talk about today. So what network is used by godwits in the Tagus? I'm not talking about a social network, I'm talking about the Tagus network. So I went into our database and I found the examples where a bird had moved from one site to another during a winter. And I collected this up for every bird that we had data on in the Tagus, which was about 600 and something individuals for 20 years. So it's a huge amount of data on how birds use this space, both within and also outside the protected area in the more urban part of the margins. And this builds up a large network that looks like this. And then we can use that to answer some questions. So to what extent is our marked population of godwits protected by this protected area? But overall, the statistics look quite good. So about 80% of these birds are using the protected area. But there's seasonal movements. So like Portuguese people, Portuguese godwits really like eating rice. And after Christmas, they go into the rice fields in the north of the protected area, and they stay there eating rice until they migrate. But in the earlier part of the winter, very few of them are using the protected area, and a lot more are in the unprotected parts around the towns of the margins. So I should say on these graphs, every square is 1% of the population. And we can see in the early part of the winter, only about 25% are protected, and then this goes up to nearly 90% in the late part of the winter. Okay, so what about the impact footprints? I'm sure some people are aware. This is apparently the best place to build an international airport. And impacts of airports on birds can have a variety of negative effects. One that's been getting a lot of attention here is noise. So this is a study on how water birds respond to noise. And the short answer is that about 55 decibels, you can start to see behavioral changes. And at 65 decibels, half of the birds in this study had altered their behavior. And we can draw the extent of this noise on the map from the airport. So this is the 65 decibels noise right through the middle of the intertidal area. And the 55 decibels is a quieter noise, but it's spread over an even wider area. And then we can calculate all the sites that we know godwits use, the extent to which they'd be impacted by this level of noise. So I did that. And then I also looked at how birds are moving in and out of the noisy area. So just like I looked at this protection footprint, I looked at the potential impact of a noisy airport. And again, in the late part of the winter, when a lot of the monitoring counts were conducted, these birds tend to be in these rice fields, which are about as far away from the noise as we could be. In the early part of the winter, over 75% are using parts of the estuary that are strongly affected by noise. So if you don't consider the seasonal movements and the total use of space by these birds, you're potentially missing potential for heating impacts. So the final thing is, birds completely avoid using these noisiest sites. What's the wider impact on connectivity? So to do this, I simulated networks. So I started off with the real network that we have, which includes 25 sites. And then I excluded the noisiest ones. So excluding sites exposed to more than 65 decibels, gets to 22, and excluding 55 and above sites, that's 18 sites in the network. Now I have to introduce a couple of network analyses concepts, but very quickly. The first one is centrality. If you imagine a network of public transportation in Lisbon, the most central site would be Alameda Station. If you have a problem there, the network's in a lot more trouble than some other station. And so centralization is the extent to which a network has one single very important site versus lots of quite important sites. And the current network that is used is quite quite widely distributed. It's not very centralized. We start knocking sites out. We start knocking out some sites. 65 decibel sites, it basically doubles and then triples at the 55 decibel level. A network is really just a collection of any objects that are joined together. And in the technical language, the connections are called edges. The edge density is the proportion of possible links that exist. So for example, here, we see these connections, but we could also have these ones. So the edge density is 5 out of 10, which is 50%. With me so far on the math. So the edge density of the actual current network is just over 0.4. If we take out the very noisy sites, it goes down a little bit. And again, if we take out the still quite disturbed sites, it goes down even further. So to answer this question, what happens if birds avoid the noisiest sites in the network? What is the wider impact here? Well, we see there's fewer sites available, but also an increased dependence on fewer, more central sites, which potentially increases vulnerability if another impact affects one of those. And there's also fewer connections between the remaining sites, which I think is interesting, because this is the proportion of possible connections between the remaining sites in the network. But even then, the ones that remain are more poorly connected because of what we showed. There's kind of a barrier effect through the middle of the estuary. And so if these sites cease to be used, there's potentially an interruption of connectivity throughout the estuary. So I don't know, it's still kind of in the early stages, but I thought this is using tracking data plus network analysis seems to be a nice way of getting quite robust and data-driven arguments, really, about connectivity and potential conservation problems. And we could potentially even scale this up to a migratory context, which is the sort of thing that Jose was talking about yesterday morning. And so with that, I'm just going to thank all the people that collect data, my lovely group, and you guys. Thank you very much.